Hi everyone, in today's session we are going to see about inter-process communication in operating systems. Let's start the session. Basically, a process can be subdivided into two types. One is independent and another one is cooperative. A process is said to be independent when it can't affect the other process while executing in the system. Any process that does not share data with other process is known as independent process. A process is called cooperative when it shares the data with other process in the while executing in the system. And the cooperative process can affect the other process while executing in the system. These are the major two categories of a process. This cooperative process requires inter-process communication mechanism for exchanging of data and information in between other process while executing in the system. So the inter-process communication is a mechanism which is used for cooperative process. Let's see how to implement inter-process communication in this session. Okay, first let's see what are the reasons for providing process communication, that is process cooperation and cooperating process. There are four important reasons. First one is information sharing, next it is computation speed up, then third one is modularity, finally fourth one is convenience. First, information sharing is nothing but since several users are using the same information, they must be provided with an environment of concurrent access for information for all the users simultaneously. That is the information sharing purpose. Then the next one is computation speed up. Computation speed up is nothing but if we want a particular task to run faster, we can break that process into a subtask and each subtask will be executed parallel in several processes at the same time, and finally the result might be gathered together. This will achieve only if all the processes are running under multi-processor environment. In this time, if we comparatively one process is executing a complete program, it will take longer time. But if it is subdivided and runs in multiple processes, obviously the time period will get reduced. For example, if a processor is executing a task for 10 minutes, and if that same process is subdivided into 5 tasks, and 5 threads are running in the 5 individual processes simultaneously, then finally the answers are combined together. Obviously the 10 minutes process execution will be completed by 5 process in 2 minutes, right? So this is the computation speed up scenario. And then third one is modularity. In modularity, we may want to construct a system in a modular fashion by dividing the system functions into separate process or thread. This is the mechanism I have explained previously in computation speed up also. That is, a single function, single process work is subdivided into one or more threads and each can run separately. And then finally it is convenience. Convenience is nothing but an individual user may work on many tasks at the same time. This is known as convenience. For example, the user may be using multiple uh, works and apps at the same time. For example, he might be editing in a Word file and he might be listening to a music, and while the same time he might be running some other programs. These are the few examples. For example, in a mobile itself, we are performing multitask, right? something will get downloaded, and at the same time we will be in chat box, at the same time we will be speaking in a call, right? This is the simple example for convenience and processing multiple tasks at the same time. So these are the four reasons for providing process cooperation. This process cooperation can be implemented using interprocess communication. Let's see it further.